and .NET. So first things first, about me. I have a confession. I'm not a network person. I'm not even really a security person. I'm a programmer. I hack code and I don't hack networks. So people always ask me, they're like, it'd be so much easier if you just like rooted the server or took over the router or whatnot. I'm like, yeah, I probably would. Too bad I don't know how to do that. So I have a different approach to things. I work at a company called TCC. There's my obligatory plug to the place I work. They asked me to do that. And I run a blog called structuredsite.com. So if you'd all just like go and hit that a whole lot of times, I could really use the hits. Anyway. So why give this talk? It's a really good question. So really and truthfully, the .NET framework for non-.NET people is really, really big. There's a lot of intricacies to it, and a lot of people don't understand most of it. In fact, myself included, there's things I've never even touched in there. I don't even know how it works. And so what that means is that there's a lot of potential for things to go on that people don't even, they don't know about. The other part is that is normally the dance between developer and operations. And every place I've ever worked, pretty much they don't ever talk to each other. And in fact, one group generally, and this can go on both sides, hates the other group, and the other group kind of treats that first group as like sort of with a mild neglect. And the problem is that they're both really good at their jobs. They are most of the places, but they don't really talk. They put half the puzzle together, but they never really figure out that maybe they should talk to each other and put both halves of the puzzles with each other. And ultimately, this leaves holes. So the next thing too is that most of this is server or focused around things that you can hack on a server, things you can do with .NET, but some of it's for the client too. But really and truthfully, the biggest pushback I get, especially from like the security auditors and stuff, when I tell them that there's a hole, is that they said, oh, well, we'll never get onto the server. We're protected by that. In truth, every time that I've needed to add access to a server to do something, I haven't had that much problems doing it. And on all seriousness, like bring candy, and generally somebody will be like, oh, here's access, and just grant me access, and then I can do things that are not nice or unkind if I need to. So that's true. That's been my experience. So most talks focus on doing things like taking over the network, stuff like that, or stealing stuff like, everybody mentions Target, but Target's such a great example because we all know them, where they steal accounts and stuff. But really and truthfully, there is another type of attack that we don't really mention too much, and I don't think it's that we don't care about it or the fact that we're afraid of it or anything like that. It's just that it doesn't gain the publicity. And what the truth is that there's a group of people out there that don't really care about making money. They just want to hurt companies. They're disgruntled or something or some other, or maybe it's the fact that they have a righteous agenda. So that's kind of what we're going to focus on today, much more insidious behavior of burning things to the ground. In truth, I put the hackers thing up there because my friend dared me. He's like, you're going to a hacking convention. He's like, I dare you to put something from hackers on there. So there we go. We're going to talk about a few different areas today. Really and truthfully, I'm trying and give something for everybody. So if you hear the first part of the talk and you're like, oh God, he's talking about that. Why is he talking about that? Hopefully, we're going to start basic and we're going to go up and then hopefully, hit some of the more advanced topics that some people like. But hopefully there's something here for everything. So the first thing I want to talk about is the configuration files. Most people kind of look over that. They're like, why would you hack a config file? I'll explain that. Next, we're going to talk about IIS. Where you can find things, what you can do with them, things like that. Then go into things that are in assemblies. This normally is overlooked by developers, how you can gain access to them. Most people don't even think about what happens after it gets compiled. Then we're going to talk about memory things, how to get stuff in programs while they're running, and then eventually I want to follow up with code replacement, which is kind of a fun topic that freaks most developers out when I tell them I'm going to hijack their system with their code. So starting out. Going with the low-hanging fruit, configuration files. So in .NET, specifically in IIS, with the web config, but everything in .NET with the machine config, is that there's actually kind of a set of configuration files that's included with every server, and they're called the machine config and the web config. And I put these two images on here because I wanted to show you exactly how many different machine configuration files there are. And so every one of those folders has a different machine and a different web config. So what most people don't think about is that they're really, really easy to get to. And as time goes by, most people kind of forget about them. If you go to a developer or a network person and be like, by the way, did you know you have 8 copies of machine config on your box? They're like, what are you talking about? And what it is that each version of the .NET framework, you got to remember there's 1.0, 1.1, 2.0, 3.5, 4.0, 4.5, now there's 4.6, and so on. And most of those have their own runtime environment, which means they have their own machine configs. There's also a 32 and a 64-bit. And so when programs migrate over time to higher level of frameworks, if nothing else to fix bugs or to make it more current or whatever, most developers, most people kind of sort of forget maybe that's there. And they'll leave things like connection strings or account passwords or stuff in older versions of the machine config. And that just kind of sits out there for forever. And you know, eventually people go, well, maybe we should encrypt it or whatever, and then they forget about the ones they've left out there. So it's like, hey, we've encrypted the values here, and then they've forgotten all the other unencrypted ones, so that kind of defeats the purpose. So as an example, I gotta remember that my mouse does not work on the felt. So as an example, I love PowerShell, by the way. If you don't know PowerShell and you're rooting into Windows boxes or whatever, just general administration, I highly recommend learning it. And if nothing else for this is that most people forget that PowerShell is actually like a .NET program. It's a .NET language that has all the same access to assemblies and whatnot. And so people are like, oh, well, you can only access the machine config programmatically through a .NET program. Well, we're never going to allow an executable to slip onto the environment. It's like, wow, darn, you got me. If only there was an interactive scripting environment that was on every single Windows box. Shoot. Oh, wait, no, there is. So in here, what I've done is that I've written all my scripts out beforehand because I really suck at typing, and I really suck at typing under pressure, and having you guys like watch me debug stuff for like a comma, I figure is probably not a good idea. So in truth, like once you got this down, it's really, really easy to remember because with this, all you need to remember is the system.configuration.configuration manager namespace, which is the same thing that all .NET programs use to actually like access machine configs or whatnot. So once you figure that out and you own a basic PowerShell command, you can pretty much steal anything from the machine config that you want ever. So for example, with this, so I'm going to clear this out real quick. There we go. So with this, I've loaded in a connection string and then just a sample, what they call the app settings in here. And like I said, every single application in .NET that runs against this server has access to all the files. And people think like, oh, it's a connection string, it's connected. I have to have administrative access to get to the machine config. It's like, yeah, okay, that's true to alter it or to open it with Notepad and stuff, but it's like now we have PowerShell. And all I have to do is click the run button. So if you look up here, I have my joke. So you have the super secret password, which is the app settings key, and then this is the answer. And if you look down here, this is the really fun part with the connection string. So in 2 lines of code, I've now just stolen every possible setting for the machine config in the connection string. So the truth is that the machine config does have some actual use for it. It's really great for allowing us to segregate things between environments because it doesn't move with the code. But the problem being is that most people forget that there's also a really, really nasty problem of us leaving things open for people to steal. Sorry? Yes. Yeah. Like I said, not to alter it. If you're going to actually like alter the machine config, Microsoft was actually smart enough to say like maybe you should have administrator access for that. But yeah, as far as like read-only values and whatnot, yes. Oops, wrong one. Here we go. So. The real question is like, how do you stop people from accessing the machine config? The real truth is that you don't. Just as a word to the wise, don't go back to your boss and be like, we need to delete all of these off the server right now. That will end in unfortunate things, like as in not working. So the real truth is that for the machine config, the best option is just to not use it. I mean, in all honesty, the machine config, at least for developers, is really centered around having things segregated to an environment, and it makes sense too. Like, you may have in your production environment, you may have the tech support email that when you have an error, it emails that. Well, you don't really want that in the development environment because you don't want your network guys like freaking out every time a dev brings down the dev box, probably. But the truth is that makes it convenient, and that was great like 15 years ago. But now there's not really a real use for it. This can all be handled through other means of not using it by doing change management controls. Now, like Octopus Deploy, Urban Code, which is now owned by IBM, and Microsoft even has their own called Release Management, where it can automatically drop files in. It can make changes to the local web configs or the app configs for applications on the fly when it deploys it. And so there's really no need to leave all of that stuff hanging out there. anymore. In truth, like if your organization doesn't have an automated management system for deploying code, I still highly recommend doing it because it's gonna save you in more ways than one. So it's kind of like you just get an added security benefit for implementing something that probably your organization should have anyway. The last part of it is that you absolutely have to use it just to encrypt the data. I mean, you know, it's not great that somebody steals like the encrypted passwords or stuff, but they're still encrypted. So, you know, you still get an advantage of that. It's not like they can take it and then immediately use it against you. So, next I want to talk about the configuration files, mainly the web, well, actually not mainly, the web config and the app config. Now, for non-programmers, these are located with the applications, and this is for, you know, things that you want to change on the fly. You don't have to recompile programs. Maybe it's like the logging lever or whatever, but they can also house sensitive information. Most organizations, this goes back to the change management thing, most organizations have horrible migration practices. Like I did change management for 4 years, and we had an automated system, but most of the time when you go into an organization, what you see is that you'll have one, and we'll say like you have the production database password, and what they'll do is that one section of the configuration file, they'll have that commented out, and then in the testing environment, they'll move the code and they'll uncomment the testing environment password, but they just leave everything in there. And so that makes it really, really easy to take. Really and truthfully, they shouldn't be in there for that environment anyway. And then truth is that most developers, as time goes by, they just don't bother cleaning it up. Like there's a lot of extraneous stuff in there. It's a lot easier to comment something out and then uncomment it later than it is to delete it and then have to go through source control. Although it's not really true, but that's kind of the easiest comment of doing it. Now, in truth, most places have really, really bad security practices around their applications. And so the first thing you do when you get onto a box, if you want to find out everything, is you just do, going back to the PowerShell thing, the first thing you do is you just go and you run a PowerShell command. The get child item star config recurse get content will actually take everything for you. Oops. So as an example, horrible at typing, so I'm stealing this. So as an example, now when I type this in and I go to the root of C, anything that I have access to automatically, I've just stolen the content for every .config file for every application across the entire server in one line of code. And the reason why this works is that most of the time we're really, really good at segregating some things and not others. But so with this, now you're right, like most people go, well, you have to search through every config file for what you want and open it up and copy it. Well, now I can just aggregate it and I can get onto the box, steal it, and then take it. Not too difficult. So really and truthfully, this goes back to what I was talking about segregating data. The easiest way to stop this is just block access to the directory. And this is the thing that I see over and over and over again. Most of the time, especially on web servers and whatnot, we're really, really good at securing like the program files directory because nobody ever wants anybody to touch in the program files. And that makes sense. There's probably downloaded code or installed applications and stuff. When it comes to like our business data or our business intelligence data, what we do is normally we just hang a folder off of the root of C and we're like, okay, point IIS to this. And it's like, well, who needs access to it? And it's like, well, obviously everybody needs access to it because on a server, everybody should have access to our business logic that's probably unsecure. And so the easiest way to do this is to just block access to the directory. Like if you have IIS and that's the only thing that needs to have access to that folder to serve pages, lock it down there. Don't allow other things to do it because if somebody gets onto the box, like I said on this one, all you have to do is one line of code and I've stolen all the configurations. Connection strings, email accounts, whatever you want. And then this goes back to the last one. You can always encrypt the data in this too. That's another thing to do to make sure that if somebody does steal it, then you can always at least protect it from that end. Your applications can easily be written to unencrypt the data when they need it. Now there are other problems with that we're going to see, but in truth, that's the easiest thing to do. So, speaking of IIS, any questions so far? No, great, okay. The hungover and or too tired principle is working. Excellent. So, so how many people here actually administrate IIS? A handful. Okay. So there is a little known thing. most, I've met a number of network administrators. I didn't even know this existed until a couple years ago. Most developers don't know this exists. So in IIS, there is actually one main configuration file that holds like 90% of the information about how IIS runs. This is the approximate location. I know some people are going to be like, well, we could change it, and there's actually a Windows directory, the %, system %, or whatever, and that really points to it. Yeah, I get it. But for 98% of the boxes out here, it's actually located right there. The inetserv directory, the config application host.config file. And really what this is just an XML file. When you go into the IIS management console, now I don't know about 6 is a little old, but the IIS management console for 7 and 8, when you update the console, it immediately will update this configuration file, and then vice versa too. You can actually go in and manually modify the configuration file, and then it'll update what's in IIS. So the actual great thing about this is, like I said, Microsoft, as much as we give them crap for things, they were pretty smart. Only administrators can actually access this folder. So it's not like one of those where it's like, oh man, don't get little Johnny, user access to the server because he's going to access it. You actually have to be an administrator to get it, which is nice. It makes sense. So before we go into the IIS program, before we start looking at it, just a word to the wise. Since it's located in the system.32 directory, if you guys are going to go like nosing around with it, you actually need a 64-bit program to be able to view the correct application host.config file. The reason for this is that there's actually a hidden directory in Windows called, I think it's like System32 WoW. And so if you're running a 32-bit application, and you attempt to access the directory, Windows very, very sneakily on the back end will actually automatically redirect you to another folder that's meant for 32-bit applications. It holds all the 32-bit application configurations and DLLs you need, because compiled DLLs, you have to access the appropriate one. So that's kind of how they do that. So really and truthfully, the only text editor that I've ever seen that's actually a 64-bit program is Notepad, which totally sucks because I hate Notepad for doing anything. But it's really, really convenient because it's on all the servers. But so if you do something like Notepad++ or text editor or something like that, chances are it's not going to work. I learned that the hard way. That was almost a monitor throwing event. So just a word to the wise, when we look at it, it's got to be a Notepad. So taking a look at it, like I said, we have to run as administrator or we'll throw a fit. Always practice safe computing, boys and girls. So yes, I want to make sure that opens it. So as you can see here, there are 3 config files. So like I said, it holds about 90% of the information. If you're looking for it, don't click the administration one. That doesn't have the information on it. When I was going through the talk last night, I also learned that the hard way again. It's the application host.config file. So opening this up, like I said, it's just an XML document. I want to go through this real quick and talk about it just very, very briefly, because I want to show you what's actually in it, and that will give us information for down the road. So if you go through here, it talks about the various sections. The first thing that is interesting, actually, going down, is the config protected data. So if you notice here, by default, IIS actually have 3 ways that it will encrypt data for you. It has 3 ways, WAS, AES, and RSA. WAS, the bottom one, is the default one for encrypting information in IIS. And for 90% of what goes on, you probably don't even care about that. You probably don't even know that it's there. Just remember that that's there. We're gonna see some fun stuff with that later. We're gonna talk about that. So going on down, what you have to remember is that application pools have usernames and passwords. You can set, for those of you who haven't seen IIS, you have different modes, but one mode is like run under the local system account, and then you have one of specify a specific user, and it's not a like I'll create a user on the fly. It is the like this is a window user account. And so if you look at it, I have one called admin on my box. I should have been a little bit smarter and named that with my joke that I'm going to show in a second. But if you notice here, the thing that we want to take a look at is that in the password, it has in the field the encrypted information in it. Now you kind of look at it and you're like, well, maybe it's the encrypted Windows token, or maybe it's something else. We'll find out what it is. It's actually the password. But so that's where the encrypted password actually lives. And it's when you type it in, it doesn't hold it someplace else. It's not something to go look up the password. It is the actual password for the account you've typed in. Remember that, boys and girls, when we talk about network accounts. Now, okay, so when you're breaking onto a box, sometimes if you get really, really lucky and you're trying to steal something, that password will be unencrypted. You can actually manually go in here and you can put an unencrypted password in here. So the question you're going to be is, why the hell would anybody do that? And that's a really good question. So there's actually kind of a subtle bug in IIS where its encryption keys will get corrupted and it will just stop unencrypting values, in which case there are a couple of different solutions for it, and it's just enough that if you search on the internet, you'll find people having those problems, but it's just obscure enough that there's really no answers for it. And you can fix that by just re-importing the keys. But the truth is that most people don't ever dig further enough into that. And so their approach is, instead of like reformatting the box, reinstalling Windows probably, which would have been a better solution, they just go in here manually and they just type in the password. Because if the password doesn't have an encryption thing in here to tell how to decrypt it, it's assumed that it's a plain text password, and it still works. So on the upside, if that happens and you don't want to do anything, you can get IIS to work. On the downside, that means that pretty much anybody who has access to your box and gets a hold of this doesn't have to decrypt the passwords. Not that that's going to matter in a moment, but just say. Oh, sorry. I just had to check where I was. So with this, there is actually an application, called 922. Okay, still going okay. So in here, along with this, there's actually a set of command line utilities that Microsoft bundles with every version of IIS, and it's called, one is called the app command. There's another one called ASP.NET_RegIIS. Really what we're going to talk about is the app command file. And so I think it's a legacy program. I don't know how old it is. My guess is it's probably been around forever. I've never actually seen anybody use it really outside of the things that I'm going to show you because everybody just uses the IIS management console or PowerShell. But it's still there, and you can do really, really fun things with it. And by fun, I mean terrible. So, oops, and prompt, we need that to be. Okay, fine, we'll use this. And prompt. So you have to run it as administrator if you're going to do this, which is okay. So this goes back to the, I've just created I've created a batch file to do this because I'm going to type it in wrong. But app command has a thing that will allow you to go through the entire application, all through IIS, and look at the various values and whatnot. I'll open up the notepad in a second, but I'm just going to type this in at the moment. So get application pool. There we go. So there, it went really fast. Everybody catch that? No. Okay, so what we're really looking for is that, so this just creates a dump file of everything in there. And looking at it, it doesn't look like it's that fun, but actually, real quick, before we go into that, so this is what the server setup looks like, just to show you that I'm not BSing anybody. Application pools. I have two app pools in here. We're going to be talking about the second one. The first one is the default app pool. It's called Ralphie's app pool, and then I have two sites in here. Nope, I have one site. I lied, but I have one called Christmas. So with this, so if you look in here, I've just done a dump of all the application pools. Now, this doesn't look like it's a lot of fun, except if you look right here, can everybody see that? So with the app command, remember how I just said that was encrypted? Well, I just used the app command. That's the password. One line of code, I was able to go in with an administrative account, and I can decrypt the passwords. And so this is why administrative access to an IIS server is bad. So now when you're thinking about it, you're like, okay, so why does this really matter? And that's a really, really good question. Because to get this, you have to have administrative access to the box. So I probably already popped this box. So that's probably okay. But the thing is that there are a lot of times you'll notice maybe developers need access to a network share or something else. And so that means is that I can't do an elevated attack on this box, but I can probably do a lateral attack against other boxes with this. Another great example is, let's say you've got a cluster of IIS machines. Most of the time, they'll probably use the same account and password for, yeah, I'm getting a nod, so somebody knows what I'm talking about. They'll use the same account and password across all the boxes. And so you can do really, really fun stuff. It's like, well, now that I've got one, it's like, now I have access to all of them. So that's a really, really fast and easy way to get it. Sorry? Oh, app command. Let me open it real quick. Or maybe it'll be lucky and I'll show it here. There we go. It's list app pool / text : I think it's dot star. Nope, text : star. So, and if you guys want to, since I have the website after the con's over, I'll go ahead and post all of this on my blog and stuff like that. So if you guys want to steal it later, and things like that. But there you go. That's how you get passwords onto IIS. Okay, I see one guy writing. I'm going to go on since I got to keep talking. Is that okay? Everybody cool? Okay, sweet. Is everybody having fun so far? Everybody no bored? Okay, good. Okay, so hacking clustered IIS. So this is where it gets a lot of fun. This is where I talk about why this becomes really, really fun and really, really important. So normally when you have IIS boxes, you have like a cluster. You either have hot or hot warm or hot cold or something like that. But you normally have a cluster of them because one, when sites get big enough, IIS just can't handle the load, or you want redundancy or something like that. So Microsoft actually created something called shared configuration. And this is a really, really nice thing for administrators. What it allows you to do is you can move the app config file to another location. So like a network location, or you can have other things pointed to the same boxes or whatever. But the great thing is that means, let's say you have 8 IIS servers. Like I said, I did change management. Let me tell you what sucks. What sucks is when you get a developer with a change request and they're like, oh yeah, well we need a new application pool or something like that. And you're like, I have to put this on 30 boxes. Are you kidding me? So the easiest thing to do is you do the shared configuration, you update it once and it puts it all the other places, which is really, really great. It's an awesome tool. But the problem being is that most organizations, what they do is that they're really, really good at securing the servers and they totally screw the pooch on the directory. And it's like, we'll just keep this one wide open. Most of the time I've heard it's like, why is this open? Like, well, we have to run the backup routines in case we lose it. It's like, great, maybe we should secure that for just the backup routine and the IIS servers can get it. But normally they miss that. But so the awesome thing about this is that when we're going back and talking about the encryption keys, Microsoft has a standard set of encryption keys that goes with every Windows server. And if you think about it, that kind of makes sense because you open it up and you have to be able to, like the shared configuration, they have to be able to sync. Now, there are ways of getting around that, but what this means is that if I get access to this file, the first thing people should be saying is like, well, you have access to the file, that's great, but you don't have administrative access to the IIS box to decrypt it. So what I can do is that if I get access to this file, I steal the file, I find a box that has IIS and I'm an administrator on it, and then I just put that file over the current one, and then I run it, and then I have everything. And so it's pretty much, it's pretty much one of those where it's like, great, you've secured the box and you've opened the file. It's like, well, I'll just go find another one, and then I'll come back later and steal more things. So, how do we prevent this? This is really, really great. The first one is don't allow access to the configuration files. That's a number one. Okay, on this one, I gotta admit, I haven't actually tried this. I talked to a network administrator and he originally freaked out, rightly so. And then he actually put IIS under a managed service account, and he told me that actually worked. That prevented it. Like I said, I haven't verified that myself, but that would be something to try. With that being said, is that if you look in using managed service accounts for IIS, Microsoft actually warns against it. So I wouldn't go in on Monday morning and be like, we're going to change all of them right now. I would test it out. Like, things can get a little hairy with that. But it does actually prevent you from being able to do that, from what I've been told. The real clear one is just limit the account's needs. IIS, like an IIS machine or an IIS account, does not need administrative access to the server. It does not need administrative access in the domain. And so, the first one is you got to understand that actually is a prime target for getting hacked. So, and the last one, I've never actually seen anybody do this, but it is possible. You can actually go in and you can alter the encryption keys that Microsoft uses. You can set up your own ones. With that being said, if you're going to do that, I would seriously consider taking a backup of those keys. One, because if you lose them, or if something happens, everything's encrypted with those keys. The standard ones won't work anymore. And two, like I said, and this actually happened to me, this is how I actually figured out all of this, is that the key store can get corrupted and you have to re-import the keys to do anything. And so, having non-standard keys means that. So, pro tip. So speaking of altering the keys, if you're on the box, you have administrative access to the box and you're actually hacking it, you might as well just go ahead and steal the keys too, just in case. I mean, like, you know, that's just that whole being a thorough thing. If you're going to steal the config file or whatever, you might as well just steal the keys too. Or better yet, if you really want to screw with people, because most people don't even sit there, just create your own keys and re-upload them to IIS and watch your network staff like freak out for a few hours trying to figure out exactly why it doesn't work. That one's a lot of fun. So, assemblies. I know we kind of jump around a little bit. So assemblies, one of the, I hope people are having fun with this. I love talking about this in freaking devs and admins out. So the thing about assemblies, most developers, when they create assemblies, and they're like, oh man, well it's in IL code or it's in bytecode. It's totally protected and safe. Yeah, not really. The truth is that the data is still in there, and one of the things that most developers forget, and especially like, anybody here actually have code that they give to clients or third parties or something like that? .NET code, anybody? So on occasion, it's true. I've been on both sides of the fence. I've had ones where we have to give it to clients, but I've had ones where clients are like, you can use our DLL to access our web servers and you call these methods. And most of the time they think, well, it's totally secure, like nothing's ever going to happen, they can't figure out passwords or whatever. This is not true. They have really, really expensive programs that you can use to decompile these, and by expensive I mean free. ILSpy, I believe, is by Telerik. I don't use that one. .peek is by a company called JetBrains, and that's actually the one I prefer. But I want to show .peek. With this, there are actually other ones too. When you purchase Visual Studio, and by purchase I mean download the Community Edition for free, it includes one called the IL disassembler. We're going to talk about that in a moment too. But so there are a lot of programs that you can go into an assembly and you can just find stuff. Now don't be afraid of it. Like everybody's like, oh man, I hate looking at IL code. Not true. So I actually I created a little like test program. You're gonna have to take my word on it. I created a little test program that goes through, and it does something really, really dorky. It says, hey, would you like to add two numbers together? And then it says, okay, input your first number and input your second number, and then it adds the two numbers together. And then I compiled it. And then I opened this up with JetBrains.peek. And so, as you can tell, this is really, really difficult IL code to read, as in like it got decrypted or decompiled from C# or into C#. And so this is all from the assembly information. Like this went from a .NET language to IL code back to C#. And so with a free tool and about 4 minutes worth of work, I can steal everything in here. Algorithms, strings, whatever you want. It's automatically all there. Now, I did something very, very specific to prove a point, is that I did not actually write this original program in C#. I actually wrote it in F#, which is another Microsoft language. And the reason I did that is that what I wanted to say is that just in case there's some like development manager or somebody who doesn't know anything about .NET, and they say, wait a minute, I've got a really great way to secure our codes, that we're going to drop programming C# or whatever, and we're going to write everything in COBOL.NET. Doesn't work. It doesn't work that way. It goes from whatever language to IL back, and it can get decompiled into any language you want. .peek just happens to pick C# with it. But like you said, if you're going after information, you want to steal stuff from an assembly, it's about 3 minutes worth of work. So, with that being said, what do we do? That's a good question. So, Microsoft, when .NET was first released, they realized this is actually a problem with putting things on third-party assemblies. They have some forward thinking every once in a while. And the truth is that there's a thing called obfuscating code. The one I'm going to show is by a company called Preemptive Solutions. They have the .NET code obfuscator. And so you can do various things with it. Is that once it goes into IL code, it will rewrite the code for you so that it will make methods, it'll change method names, or it will encrypt strings or do things to make it much more difficult to decompile. So maybe it's not a 5-minute operation anymore. So looking at that, where is it? So we pull up the .obfuscator. So this is actually a really big program. This is their professional edition that I pretty much told them I was giving a talk, and I begged them to give me a trial license long enough for me to actually demo this. I don't know how much it costs, but it does work, and there is actually a free version too. So with that being said, you can open it up. You have various settings that you can change. So input, I've set all this up before. So the application that I just decompiled and I showed you through .peek, this is the exact same one.
You can go through and specify what method you want to rename. The most important one I want to show is the string encryption. And so what this will do is this will actually take a hard-coded string in there. Let's say that you're not saying you should do this, but let's say that you're hard-coding your connection string information in an assembly or maybe some logic or something like that. This will actually encrypt the strings for you so that you can't open it up in the assembly anymore. Once you hit the build button, it goes through, it runs through, and it recompiles it. So now, so this is the original one that I just did. Now, if we go and, so this is the new file it put it in. At least I hope it is, because I'm going to look really bad if I'm not. It's not. So we look at this. So if you look up here, it says .obfuscated code not supported. And so you've got the beginning application, and then you've got the end application after .obfuscation. And so .peak can even decompile it. Now, with that being said, this is where we're going to go into the IL disassembler that's run by Microsoft. Just because it can't decompile this does not mean it's perfectly safe. It's not like, oh, game over, yes, we totally stopped all the hackors and stuff like that, hackors, or whatever. There are still other tools in there. So if we open up the same application, and this is actually, the IL disassembler is from, like I said, the Visual Studio tools for Microsoft, so it's also free. When you open this up, now when we look at this, you can open up the program again. Just because it can't be decompiled doesn't mean you can't look at the IL code. And this is actually really, really important to go through, really, really important to understand, because it's not a game over thing. And you think about it, that makes logical sense, because in order for the .NET runtime environment to run it, it still has to be like understandable. And so you can still access it. But looking at this, so if you look at get numbers, I know this is a lot of, where is it? Trying to find my specific example. String. Wait, no. Oh, main, here we go. So normally, quick IL code lesson. So the LDSER stands for load string. Most of the time when you see this and you have load string, the load string is actually just a hard-coded value. You can open it up, you see all the hard-coded values in there, but what this has actually gone on and showed is that the obfuscator actually has a way of encrypting it and changing it to a byte array so that you can't actually just pull it out of the assembly code. So it does give you some leverage or some leeway. It makes things a little bit difficult, but not impossible. So this is where we talk about going in and hacking things in memory. They claim it does not. I haven't actually done further tests, but if you look at preemptive solutions like obfuscated code, it talks about how it actually makes things more efficient. You can set things in there by like compiling things together and whatnot. I mean, if you want to talk about it on an actual like, ticks level, I can't see how it wouldn't add a little bit, but I can't say for certain. And there may be something, they may do some like wicked magic in there to begin with. If honestly, if it gets to the point where that's actually slowing things down, yeah, I would look at other things first. But my guess is that it's not going to be noticeable, but it's a good question. So the first thing we're going to talk about before we go back and obfuscate all the things, remember you are actually changing the IL code, and so don't go back and don't tell your developers we're going to do this and then move them to production environment on Monday morning, because it can screw up things like reflection or whatever. Just because the IL code, just because the Microsoft linkers will link everything together and make it all work, there's actually like runtime things you can do to look up assemblies and stuff on the fly, and that actually, when you change names around there for it to look up, that'll mess up that code. So before doing that, just go through and test it. So going after memory. Wow, got to talk fast. Okay, so going after memory. So when we talk about this, how .NET works. .NET works is like Java. It's a runtime environment, and this is really important. It's not one of those. It's not like C. It's not like compiling to bytecode where you have to like manually allocate memory, and then when you're done, you deallocate it. The great thing that makes .NET so wonderful, actually, for programmers, when I speak this, I totally rely heavily on it, is it's got a garbage collector. And so what actually happens is that you put something in memory and you use it, and then you tell .NET, hey, I'm done with this. And the garbage collector, when it needs memory, it eventually runs, and it will eventually reclaim the memory. But what this means is that just because that you're done with, let's say, a connection string or a password or something, and it goes what they call out of scope, or it's not being rooted anymore is the official term, it doesn't necessarily mean that it's out of memory. It just means that we're not using it anymore. And the garbage collector will say, like, look, when I get to this, that's cool. Like, I'll free up memory when I need to. So there's no count on it. Now, somebody's going to say, like, well, you could just use GC collect and you can force that out. That's kind of true, but it's actually not really true. That will actually allow you to free up space, but it's not a security thing. It doesn't work that way. And what that happens, the reason being is that, one, we don't necessarily, if somewhere else in the program, strings or whatever are being used either by the runtime environment or in there, or not to mention the fact, like I said, .NET actually has certain optimization things, especially around strings, because strings are immutable and they can reside in memory. It will actually like take a string and it will reserve it itself to have faster access later. So using GC collect can be like, oh, well, it gets rid of it all the time. It doesn't. You might get lucky sometimes. Not going to say you're not, but you might not get lucky some other times. So it's not a security thing. And the reason they do this is that it's purely for speed. The garbage collector is not meant to be something to clean up like insecure applications. It's just meant to be there to keep the application running on the server. So with this, if we're going to hack memory, you have two ways of doing this. If you have the ability to get into a server on a box, it's really, really easy to create a dump file. A guy named Mark Rosanovich created a thing. He's really, really smart, wrote a lot of Windows tools, wrote a thing called proc dump. And you can just point proc dump at a running application and tell it to grab a dump file. And it creates a dump file for you. That's actually what we need. If you can't get it on there, really and truthfully, the other thing you can do is just wait for a crash. On Windows 2008 and beyond, there's a thing called Windows Error Reporting. And this is a set of registry values that you can pretty much tell the Windows operating system, by the way, when a .NET application, when a non.NET application crashes, now I know we're talking about .NET, so I'm going to go back and say, when a non.NET application crashes, go ahead and produce a dump file and put it in this location and save this many for me. Now I said it's a non.NET application. It's like, well, we're talking about .NET. How is that going to help me? That's a really great question. Remember, IIS is not a .NET application. So you can point this at IIS, say like, when this is done, produce a dump file, and then grab the dump file from there if you can't get proc dump. So that's your other thing to do that. But that's just a thing to note. Oh, and when you do this and you check, if you're actually going to attempt to hack a box on this and do that, and you're checking in the Windows Error Reporting, the next thing I would do is to make sure that somebody hasn't set up a task to be like, hey, why don't you email me every time this produces a dump file, because that'll kind of give it away that you're trying to produce a crash. Just a word to the wise on that one. Pro tip. So tips for creating a crash. If you're actually going to create a crash, the first thing I would look after is actually the logging system. Most places don't use like a professional solution. There's one called AntLib, the enterprise library for Microsoft. I never use that one, but there's other great ones out there called nlog or log4net, which is based on log4j. It's really, really old. But the truth is that most places want to roll their own because they think it's cool to write things. I like it too. It's cool to write things. But most people forget that you should not attempt to log that your logging system failed. Because what happens is, and I've seen this multiple times, is that the logging system goes offline, so like database goes offline, or you've got a text file or something like that that you lose access to. And what happens is that, so an exception occurs, it attempts to log the exception, that fails, then it attempts to log the fact that the logging through an exception, and that fails, and so on and so forth, and so on and so forth, and on down. And really wonderful, that creates a Stack Overflow exception. Stack Overflow exceptions, before anybody gets out there like, well, we should just try catch it, does not work. You cannot catch you cannot catch a Stack Overflow exception in .NET at all, ever. End of story. Constrained execution runtime, things like that, does not catch it. It will not do it. You hit it, your application is going down. That's just all there is to it. That being said, that makes it great for us because hitting the logging system, like I said, if you want to create a dump file really, really fast, that's the first thing to do. Pro tip, if you're going to do it on IIS though, IIS has security features that will shut down a website if it runs into too many crashing exceptions within a 5-minute period. So if you're going to shut off the logging real fast to grab a dump file and steal it, make sure you do it really quickly and then turn it back on. Because generally I found that people tend to notice, not when IIS crashes because it's very good at recovering, but they tend to notice when the whole site goes down and stays down. Just throwing that out. So, accessing the dump files. What you're really going to need is, there's a tool by Microsoft called WinDebug, and that actually, you can actually do it through Visual Studio too, but I use WinDebug just because that's what I'm used to. And on .NET, you're going to take these 3 files, the SOS, the CLR, and the MS Core, I don't know how to pronounce the last one, the other one. These have to line up with your dump file. So if you're in there and taking a dump file or you're looking at it, you want to make sure that you grab these 2. Just as a note. Sometimes you can get lucky if they're a little bit off, but it's really while you're on the server just to go ahead and grab these 2 that are part of the .NET runtime environment. So, showing really quick what I mean. I went through and I created a dump file last night, just so I didn't have to do it. WinDebug 64 or 86. You just go to open crash dump, obfuscated code. This actually brings this up. So what I did, just as a note, so I actually ran this against the application that I obfuscated earlier. So it has all of the encrypted strings or whatever in there. And so what I want to demonstrate on this is just because you've encrypted the strings doesn't necessarily mean that it's protected. It's protected from someone stealing information in an assembly. So the first thing we need to do is there's a command .load by, SOS, CLR. I'm not great at WinDbg. I can memorize things. But this is the thing you want to know if you're going to steal strings or whatever. So once you load that in, not it. There we go. WinDbg is fussy about setting things up. So I normally don't like writing this in. Spaces actually really do matter in this part of the application. So if you want to go through and you want to steal strings off of and in running memory, that's the command. It's not anything special. What it does is it says loop through, find this type, and then find the memory offsets for this type, and then print it out for me. Like I said, I'm not a great WinDbg master, but I do know that I can write that down and I can do what I need to do. So with that, oops, wrong one. Here we go, WinDbg, Control V. There we go. So I know I'm kind of going fast. What I want you to see is that if you remember in the original assembly, it had down at the very bottom, add two numbers and then first number, and that was hard-coded into the assembly. With the obfuscated code, what that actually did is that it encrypted those values. And so in the runtime environment, in order for something to use it, it still has to decrypt it. So even though you've encrypted something in the assembly, it doesn't necessarily mean that it's safe. If someone gains access to the memory dump file, they can still get the passwords or whatever they want. But so showing this, like, that's an easy way around it. It's like, well, shoot, they've encrypted it. Great. Load the assembly into memory, grab the dump file, and then grab all the information from that. Problem solved. And so that's the way of getting around that. Questions? So there is a way actually to solve this. Microsoft created something in .NET 2 because they realized this is a problem in .NET 1 called secure string. Most places don't use it, mainly because it requires you to turn on unsafe compile settings, and it's actually kind of difficult to use, but it is possible. But just because you encrypt something in an assembly doesn't mean it's safe from attacking in memory. So the last thing I want to talk about really, really fast is rewriting code. And this is something that kind of freaks people out when I talk to them. Now, I have to admit, I was doing research on this the other day, and I feel like I really had I'm a moron moment because I brought an article up, and they said, hey, if you're going to rewrite code and you can decompile the code into C# code, why don't you just recompile it from that? And it's like, damn, that's a really brilliant idea. That was, yeah, I felt like a moron with that. With that being aside, there are actually, this has been around for a long time. Microsoft actually touts this as an advantage to the .NET runtime environment. It's really, really easy to do IL rewrites in code. And so what this really means is that if you give an assembly to somebody, or if somebody gets a hold of assembly and they want to start jacking with it, there's nothing to stop them from doing that. In fact, the Mono project has something called Cecil, and it's been around since like 2007, 2005, 2007, or whatever. So Cecil's actually been there a while, and it's a .NET rewriter for you. Now, there are other things out there if you want to manually go and you can pay money for a thing that'll bring up the IL code and you can modify it. But Mono is free, and so is Cecil. So in about 20 minutes worth of downloading stuff and compiling code, you have a thing that can actually rewrite code for you. And so with this, now what I did was, 1 minute. Okay, so what I did is I actually had to create a different program that mimics my first program in F#. And I'm not doing that to hack people. I'm not doing that to pull wool over people's eyes. Really, the truth is that F# is really, really good at inlining code. And when I attempted to do this, I forgot about its inlining code thing. And when I rewrote the binaries over and over again, it didn't work. And I was really angry. And then I realized, oh, well, it's because it's inlining code. It's actually ignoring the methods that I'm inlining. But with this, I created the exact same thing. Looking at it, there's a program. Add two numbers together, number 1, number 2. It looks exactly the same. So let me bring it up real fast. do it in debug. Okay, code alter. So if you look at it, add two numbers together, number 1 comes up with 5. Excellent. So with that, now if we run the altering code program, see, this is about, oops, wrong one. With this, what you're going to see is this is about what, 20 lines of code? And what this is going to do is there's a method in it that says, hey, add two numbers together. And I'm going to take a compiled assembly, I'm going to rip everything out, and I'm going to replace it with my own assembly information in there, all within 20 lines of code. And this is actually really, really easy. You're like, oh, you have to dig through IL code to do that. No, you don't. With Cecil, what it'll actually do is you can actually use this for a discovery too. You can pull out method names, type names, class names, whatever you want. And so you can do all the discovery with this also. It's not one of those where you have to be a genius to understand like bytecode or whatever to get it. It all takes that out for you. And so with this, if I want to hijack somebody else's code, please work. I bet it's... Okay, one more time. Directory not found exception. You lie. Okay, so that's supposed to work. Fortunately, I actually went through and I created one beforehand. So through the exception assembly, I also added that in too, because why not? But so with 20 lines of code and stealing and sending the application, so before it added two numbers together, now I just had it return the first number automatically. But if you think about it as a way of hacking an assembly, you could take an assembly, alter it, give it back to other things that call that assembly, and you've just altered the execution environment for it, all within like 20 lines of code. So as far as like hijacking assemblies and whatever, if you give it to a third party or whatever, it doesn't necessarily mean that it's secure. It doesn't mean that like they can't alter it or do whatever. They may be able to steal information. They can also do whatever they want with it. Now the way of getting around this is actually what they call strong naming assemblies. And so what this means is that anything you give out, and you may even put this on your own environments too, is that and if assembly gets altered, they have to remove the strong naming, which is essentially like a hash and assigning saying like, yes, this is the assembly, yes, it came from this corporation. And anything else that calls it automatically looks that up. And if they are accessing a strong naming assembly, and if it doesn't work, it automatically throws an exception, it won't work. So, very quick primer on rewriting code. And I am out of time. I apologize for running over. So, oh, yes. Oh, as far as rewriting code, so there's a thing called strong naming assemblies, and Microsoft allows it when you compile code to say like, this is my company key. I intend on strong naming the assembly, and it will go through, and what it does is it generates a hash based off of like the code contents, and then it signs it with that key. And so what happens with that is that any other program that then calls that assembly, it immediately says, oh, well, this is a strong name assembly, and it looks up the version and the hash for it. And so if an assembly gets altered and put back in place, if that calling application calling that assembly doesn't have the hash code match and the signed key information in it, it immediately says, wait a minute, something's wrong. This was strong name. It's not anymore. I'm not going to run it. And so that prevents tampering. Well, thanks. I appreciate you guys coming and listening.